My name is Abdul Raf and today we will look at Lect 2 of DSP, which is related to signals and system. What is a signal? Signal is a physical quantity that changes with respect to any independent variable. What is system? System acts as a processor to create other signals. In DSP, systems are also known as filters. Basically a system takes an input signal, apply different operations on it, and give an output signal to it. Look at an example of a function. First of all, this part of our function is our output. This part of our function is our input, and this part is our system. Now, looking on some of the basic operations of signals that we will be looking in this video are flip, shift, and scaling. About flip function, this is the basic equation of flip function. Y of n, which is our output, should be equal to x of minus n, and x of n is our input, and x of minus n shows us about the basic equation of flip function. This is our x of n, which is our basic input of this signal, and after applying flip function to this signal we get this output as y of n. Here, let's talk about some mathematics. From here, y of n is equals to x of minus n. Now let's take calculate the value at y of minus 1. Y of minus 1 should be equal to x of minus 1, that will be equal to x of 1, that is equals to x of 1 is equal to 1. So here we will get value 1. Now similarly, calculating at 0 and 1, we get this general trend that the values on this side of the graph will be on this side of the graph, and values on the right side of the graph will be on the left side of the graph after applying flip function. Now shift function. The basic equation of shift function is y of n equals to x of n plus k, that is for advanced function, and x of n minus k, that is for delay function. We will be taking this as our input function x of n. Talking about delay function, now our equation will be y of n equals to x of n minus 2. That means we need a delay of 2 seconds. Now this will be our output graph. Now talking about calculations, y of 0 according to this equation, y of 0 will be x of 0 minus 2, that will be x of minus 2, and from this graph we get to know that the value of x of minus 2 is 1. So our answer will be 1. Like this, we will calculate y of 1 till y of 5. We will calculate all values and plot this graph. Now let's discuss about advanced function. Now our equation will be y of n equals to x of n plus 2. This means that we need a advanced value as a signal. So similarly, like delay function, we will now calculate the values of advanced function using this equation, like y of minus 5 equals to x of n plus 2. So it will be x of minus 5 plus 2, which will be equal to x of minus 3, and at our input signal we will see that x of minus 3 is 1. So we will get to know that this value is 1. Now calculating values for all the points, and we get to know that our graph will give us last value at y of 1, that will be minus 1. So using these value calculations and values, we will plot this graph and we will get this result. Let's talk about scaling. The generalized equation for scaling is y of n equals to x of kn. If k is greater than 1, then we will regard it as downsampling, and if k is less than 1, then we will call it upsampling. This is our input function, that is x of n. After applying scaling of y of 2, and we will get this graph. See how using these calculations at y of 0, x of 2 into 0, that will be equal to x of 0, that is 1. Our answer will be 1. Similarly, at y of 1, x of 2 into 1, that will be x of 2. So our value will be x of 1. And now looking at y of 2, we get to know that at x of 4 we got no value, so we will consider it as 0. So we'll get a 0 value. Now similarly, we have calculated y of minus 1 and minus 2, and this plot is calculated. An example which involves all three functions, that is shift, flip, and scale. Now we have to follow this sequence so that we have to get correct answer. First of all, we have to shift the function, that is a shift of 3, then flip with this negative sign shows, then scale. The 2n will show us that this function is being scaled. Now this is our basic input function, Now applying shift on this function, we will get this graph, and we will follow the same procedure as shown in previous examples. Then we will flip this function, and at the end we will scale this function, and we'll get this as our final result. When we are doing scaling, our signal gets shrinks most of the time, so an error arises due to the shrinking of signals. We got three methods to overcome this error and obtain a signal which is likely to be as similar as the original signal. The first method is zero order hold, second method is first order hold, and third method is second order hold. Order hold for a sample with zero amplitude, we will simply take the value of amplitude of previous sample as the amplitude of this sample, and then we will plot the graph. In this method, error is not much minimized. In first order hold, we will use the gradient or derivative using this formula m equals to y2 minus y1 divided by x2 minus x1 to calculate the amplitude of the zero sample to calculate the amplitude of the sample with zero amplitude. In order hold, we will use Taylor series to calculate the values of next point. Taylor series is written first order and zero order. We need only two samples to calculate the value of next sample, but in this second order hold we need at least three samples. In second order hold we obtained a curved wave, whereas in first and zero order we obtain a straight or a triangular wave. Talk about the relationship between impulse and step function. Impulse function is the derivative of unit step function as shown here, or we can also see that say that unit step is the integral of impulse as shown here. Using this mathematical expression, we can make a signal out of delta. First, we will see some of the names of common signal decomposition. First is impulse decomposition, second is Fourier decomposition, third is even or odd decomposition, fourth is interlaced decomposition, and fifth is step decomposition. Out of all these, the important ones are even or odd decomposition. Now look at even signal decomposition. For this is valid for signals with even symmetry, and for decomposition we will use this formula x of n plus x of minus n divided by 2. Now looking at the odd signal decomposition, this decomposition is valid for the signals with odd symmetry. Now we will look at its formula. Its formula is x of n minus x of minus n divided by 2. That's all for today. Thank you.